The roots could be either real and distinct and could be the same roots and complex. Hello everyone, I hope you're doing great. In this video, I'll be telling you about how do we solve the homogeneous differential equations. And to explain the proof of this method, I'm going to use a second order differential equation which has a format a y double prime plus by prime plus cy equal to 0. So for equations of this format, if we have to solve them from scratch, that means that we don't have any solutions to this equation already available to us and we want to find a new solution from scratch. We need to have some kind of an idea about types of these equations and the solutions that these types of equations have. The process of guessing the solution is intuitive. So let's take for example an equation of this type, by prime plus cy equal to 0. So you must remember that this equation is a separable equation and we can write it down as by prime equal to minus cy, and then we were able to write 1 over y dy equal to minus c over b dx, and now we would be able to integrate this equation to find the value of y, and every time we did that we got a solution of this type, e to the power mx, right? Especially in the case when c and b both are constants, right? So for the sake of this proof of this method, we're going to assume that a, b, c all are constants, and we are going to guess, or we are going to make a guess, that if a first order equation has a solution of this type, a second order equation which is very similar to this first order equation, it is a homogeneous equation and all the coefficients are constants, then the second order differential equation will also have a solution of this type, which is y is equal to e to the power mx, where m is another arbitrary constant. Y is equal to, the second order equation is also going to have a solution which is like y equal to e to the power mx, where m is a constant. So just like we've done in reduction of order, we are going to take this solution and substitute it into this equation, all of this equation, and we're going to try to find the value of this m, because other than this m there is no unknown in this solution, right? So let's do that. So I have already got the value of y, I need the value of y prime, so the y prime of e to the power mx will be m e to the power mx, right? This is standard differentiation. Then if we take the second derivative, we're going to get m squared e to the power mx, right? Again, this is standard differentiation. So now we substitute all these values in the differential equation. So we get a, so we write a, then there is y double prime, so m square e to the power mx. Then we have b and y prime, so y prime is now m e to the power mx. Then we have c and y, so y is e to the power mx equal to 0. Now we immediately see that we can take e to the power mx from all of this equation and we get am square plus bm plus c equal to 0, right? So this is what we get. So we have two solutions now, either e to the power mx is equal to 0 or am square plus bm plus c equal to 0, right? So for the first option, the value of m can only be minus infinity for this thing to become true, but that is not a very useful solution for us, so we say that we're not interested in this part. So but we have been finding the value of m for certain equations of this type. If m is considered a variable here, just like x, we can apply the quadratic equation to find the roots of this equation, where m is the variable. So the value of m will be minus b plus minus square root of b square minus 4ac divided by 2a, right? So this is a very famous formula, and you should be looking at how we assume the names of a, b, c, so that we get the same formula that we already know. So these are the values of the roots for this equation, and there will be two roots. There can be two roots, m1 and m2. both will have value different, both will be different because of this plus minus sign, right? So now let's go to the method part. So for example, you're given with a differential equation. So if the equation follows this standard format, you already know what the solution is, and the task remains is that all you need to do is find the value of this m, right? So I'm going to simply find the value of m and I'm done with my problem. So let's do an example. So the formal name of this method can be homogeneous equations with constant coefficients, right? We can apply this method only on the equations where the coefficients are constant and none other than those equations. So this is problem number 7, exercises 4.3 of the Zill Cullen book. So the problem states that you need to give a general solution to the second order differential equation 12y double prime minus 5y prime minus 2y equal to 0, right? So the thing is, with the roots, that roots can have three forms. The roots could be either real and distinct, the roots could be real and they could be the same roots, like we call them repeated roots, and the roots could be complex. And in complex we are considering both that either they have real and imaginary part or they have only the imaginary part. So we can face any of these cases as a result of finding the roots for this equation. So let me explain the method to you. The first step is that you verify that all the coefficients are constants, right? So this is a constant coefficient equation, right? And what are the coefficient values? A is equal to 12, B is equal to minus 5, and C is equal to minus 2. This was the first step. The second step is that you write down this equation, which now we call an auxiliary equation, right? So let's write down the auxiliary equation. All you need to do is write the value, plug in the values of A, B, and C, and you're done, right? So the auxiliary equation for this differential equation would be 12m square. So there should be plus bm now. So instead plus bm, I'm going to write minus 5m, and then there should be c equal to 0. So instead of plus c, I'm going to write minus 2, and then we have equal to 0. So the third part is apply the quadratic formula or find the roots. So m1 and m2 will be equal to minus b plus minus b square minus 4a and c divided by 2a, right? So this is our the formula for the roots. So what would be the values? We get 5 plus minus 25 plus 96 square root divided by 24, which is equal to 5 plus minus 11 divided by 24, which is equal to 5 plus 11 divided by 24, which would be 16 over 24. And then we will have the second root will be 5 minus 11 over 24, which will be minus 6 over 24. So we can write them properly as m1 equal to 2 over 3 and m2 equal to minus 1 over 4. So these were the root values. So now we are going to write the solutions. The first solution will be y1 equal to e to the power 2 over 3x, right? So e to the power mx was the general solution, general form of the solution, and we're simply plugging in the values. And the second solution y2 would be e to the power minus 1 over 4x, because m2 is minus 1 over 4. So the general solution y would be c1 y1 plus c2 y2. So we could write c1 e to the power 2 over 3x plus c2 e to the power minus 1 over 4x. So this is our general solution. This is the answer to this problem. Okay, so this was the first type of solution, which is real and distinct roots. I'm not going to give you a proof for the following, but I'm just going to use this video just to tell you the general solutions for the other two types of roots, and I'm going to give you the proof in a later video. So the solution for the general solution for real repeated roots is y equal to c1 e to the power mx plus c2 x e to the power mx, because in the case of real repeated roots you are only going to get one solution, which is m1 equal to m2 equal to m. You can simply name it m, and you're going to simply replace that value m over here and over here, and you're going to leave everything as it is, and you're going to get the general solution for the second case, which is real repeated roots. For the third case, which is the complex roots, so if you get negative value inside the square root for the quadratic formula, which is the case which is called complex roots, the general solution for such an equation would be y equal to e to the power alpha x into c1 cos beta x plus c2 sine beta x, right? So these are, you simply make note of these solutions, and whenever you encounter these types of roots in your general solution, you simply use this general solution instead of the solution that we used over here. So this solution is only good for real and distinct roots, and for other two cases you can use the further solutions that we have shown over here. So I hope you understood the concept. This is very simple method, and it is very frequently used, so please do a little practice of this. I'm going to leave you with a question to practice, and the question is, so please do this: 2y double prime minus 3y prime plus 4y equal to 0. So try to do this. Subscribe to stay in touch, and I hope to see you in next videos.